Welcome to the video lecture series Microprocessor and Microcontroller. Paper code is AC502. My name is Dr. Anilesh Day, Associate Professor, Department of Electronics and Communication Engineering, Narula Institute of Technology. This is lecture 29. In the previous lecture, I already explained the SFR of 8051 microcontroller. Starting address of the SFR is the 80H and ended with the FFH. Now I explain in this lecture each and every register of the SFR one by one. First, A or accumulator. The accumulator of the register A is most important and most used in 8051 microcontroller SFRs. Register A located at the address E0H. The accumulator used to hold the data for almost all ALU operation. Some of the operation where the accumulator is used are: number one, arithmetic operation like addition, subtraction, etc. Logical operation like AND or NOT, etc. Data transfer operation between 8051 and external memory. The name accumulator comes from the fact this register is used to accumulate or store the result of all arithmetic and most of the logical operation. That means if you want to do any kind of arithmetic and logical operation, you first take the data to the accumulator, perform the task on the accumulator, and result will be stored on the accumulator. So this A accumulator register is a 8-bit register. It started from the bit 0, and ended with the bit 7. Now register B. Register B is used along with the accumulator in multiplication and division operations. These two operations are performed on the data that is stored only in register A and B. During multiplication operation, one of the operand, multiplier or multiplicand, is stored in register B and also the higher byte of the result. In case of the division operation, the register B holds the divisor and also remainder of the result. It also used as a general purpose register for normal operation and often use an auxiliary register by programmers to store the temporary result. Address of the register B is F0H in SFR address space. It is also the 8-bit register starting with the bit 0, ended with the bit 7. Now we explain the register program status word. It is also the 8-bit register. Bit 7 stands for the carry, bit 6 is for the auxiliary carry, bit 5 is for the A4 register, bit 4 and bit 3 are the RS1 and RS0, bit 2 is for the overflow, bit 1 is not operational, and bit 0 is for the parity. Now what is the carry flag? Carry use any arithmetic, logical and boolean operation. AC stands for the auxiliary carry, use the BCD arithmetic. F0 is for the general purpose flag, it is flag 0. RS1 and RS0 register bank selection bit. So if there is a 2 bits, there is a 4 combination, that is a 0, 0, 0, 1, 1, 0, 1, 1. When it is 0, 0, it is select the bank 0. When it is 0, 1, select the bank 1. It is 1, 0, select the bank 2. 1, 1, it is for the bank 3. These banks already I explained in the previous lecture. When I go for the location of the internal RAM starting with the 00 to 7FH, and already explained there is a 4 banks are there, bank 0 to bank 3. So selection of that bank, this RS1 and RS0 take in the action. OV stands for the overflow, used any arithmetic operation. P stands for the parity. Set 1 if A has odd number of ones. After the result, if I check if there is a odd number of ones presented in the accumulator, total number of ones is odd, then parity flag is set, otherwise reset. Now, next one is a timer mode select register or T mode register, timer mode register. This is for the timer 1 and this is for the timer 0. Bit 7 is for the G for the gate operation. Bit 6 for the C plus T bar, counter slash timer mode of operation. M1 and M0, this is the mode select register. So there is a 2-bit, there should be the 4 combinations are there. I'll explain in later on. And this portion is for the timer 1 and similar thing is for the timer 0. Similarly, gate C slash T bar M1 and M0 for the timer 0. So if there is M1 and M0, these 2 bits are there. There is a 4 combination 0, 0, 0, 1, 1, 0, 1, 1. When it is 0, 0, it is selected the mode 0. When it is 0, 1, it is selected mode 1. When it is 1, 0, mode 2 and 1, 1 is the mode 3. I'll explain all the modes one by one. When it is 0, 0, it is a 13-bit timer mode. THX 8-bit and TLX is the 5-bit. So total selection is a 16-bit. THX contain the 8-bit and TLX contain the 8-bit. But 0, 0 operation, this is a 13-bit mode. That means from the THX, it is already taking the 8-bit and from the TLX, it is taking the 5-bit. 0, 1, 16-bit timer mode. 1, 0, 8-bit auto reload timer mode. 1, 1, 2-bit timer mode or split timer mode. In mode 0 is the 13-bit timer mode for which 8-bit THX and 5-bit for TLX are used. It is mostly used the interfacing process with the old MCS 48 family of microcontroller. So it is the 13-bit timer mode. This is the D0 to D12. It is the total 13-bit and it is a combination of the TLX 8-bit. So it is a TLX 8-bit and THX 8-bit. So it is a THX 8-bit, sorry. And TLX is the 5-bit. So out of this 8-bit, this 5-bit is used. So mode 0, there use the 13-bit timer mode. Now for mode 1, 16-bit timer mode. Mode 1 is the 16-bit timer mode used to generate a delay. It uses 8-bit THX and 8-bit TLX from the total 16-bit of register. So it is starting from the D0 to D15. So it takes a total 8-bit of THX, LX and total 8-bit of the THX. So total combination 8 plus 8 is the 16. Mode 2, 8-bit auto reload timer mode. Mode 2 is the 8-bit auto reload timer mode. In this mode, we have to load the THX 8-bit value only. When the timer gets started, THX gets automatically load into that TLX and TLX start counting from the value. After the value of TLX overflow from the FF to 00, then TFX flag gets set again the value from the THX and get automatically loaded into TLX register. That's why it is called the auto reload mode. So what is this thing? I'll explain this thing once again. After the value of the TLX overflow from the FFH to 00, the TFX flag gets set and again the value from the THX get automatically related. Means when this is overloaded in this mode 2 register, then automatically from the THX value will be transferred over here. Next one is a PCON register, power control register. It is also the 8-bit register. It is a S mod. This is the GF1 and GF0 general purpose files. It is a PD, power down mode, and it is the idle mode. I'll explain one by one. Bit 7 is for the S mode, is the 1 baud rate is double in UART mode 1, mode 2 and mode 3. So what is the meaning of that? If it is a 1, what is the baud rate of the processor? That will be doubled. When it is 0, there is a no effect of the baud rate. Bit 3 to 2, GF1 and GF0, that means these two, GF1 and G0, they are the general purpose bit for the user. Bit 1 is for the PD power down. 1. Enable the power down mode. In this mode, oscillator clock turned off and both CPU and peripheral clock stopped. Hardware reset can cancel in this mode. 0 for the disable power down mode. Bit 0 is called the idle mode. 1. Enable the idle mode, CPU clock turned off, whereas internal peripheral module such as timer, serial port, interrupts works normally. Interrupt reset can be cancelled in this mode. 0. Disable the idle mode. Now SCON. This is the serial control. The serial controller SCON is SFR used to control the 8051 microcontroller serial port. It is located as an address in 90H. Using SCON, you can control the operation mode of the serial port, baud rate of the serial port, and send and receive the data using serial port. So this is already used for the serial communication. SCON register also consists of the bit that are automatically set when a byte of data transmitted or received. That means it is for use for the both transmit and receive or transfer the data from the 8051 to the peripheral, and it is for use for the serial communication. So this is the 8-bit register. It is the SM0, SM1, SM2, REN, TB8, RB8, TI, RI. I'll explain one by one. SM0, serial port mode 0 shift register. SM1, serial port mode 1, 8-bit UART plus variable. SM2, enable multiprocessor communication in mode 2 and 3. REN, set or clear by software to enable and disable reception bit. TB8, the 9-bit that will transmitted in the mode 2 or 3, set or clear by the software. RB8, in mode 2 and 3 is the 9th bit that was received in mode 1. If SM2 is 0, then RB8 is top bit and that was received in the mode it is not used. TI, transmit interrupt flag set by the hardware and end of 8-bit time in mode 0 at the beginning and stop bit in other mode, it must be cleared by the software. RI, receives interrupt flag set by the hardware and must be cleared by the software. So this is the function of the each and every bit of the SCON register. In mode 0 and mode 1, when 00 it is the mode 0, description it is for the shift register and baud rate is the F oscillator by 12. When 01 mode 1, 9-bit UART, 10 mode 2, 9-bit UART, F oscillator by 64 or F oscillator by 32. 11 mode 3, 9-bit UART is the variable. TCON, timer control mode of operation. It is also the containing the 8-bit. I'll explain the each and every bit one by one. TF1, timer 1 overflow flag. Set when the timer rolls from 1 to 0 and clear when the processor vectors to execute the interrupt service routine located at the 001BH. Tier 1 timer 1 run control bit. Set to 1 the program enabled to timer count, cleared 0 the program to halt timer. TF1 timer 0 overflow flag. Set when timer rolls from the 1 to 0 and clear when the processor vector to execute the interrupt service routine located the program address 000BH. TR0 timer 0 run control bit set to 1 by the program to enable the timer to count and clear to 0 program to halt timer. I1 external interrupt 1 H flag set 1 when high to low H signal is received at port 3.3 INT1 and clear when the processor vector to the interrupt service routine program address 0013H. IT1 external interrupt 1 signal type control bit set to 1 program to enable the external interrupt 1 to trigger by the following H signal. Set by 0 the program enable to low level signal interrupt 1 generate an interrupt. IE0 external interrupt 0 H flag set 1 when high to low H signal received in port 3.0 INT0 and clear when processor vectors to the interrupt service routine address is the 0003H. IT0 external interrupt 0 serial type control bit. Set 1 when program is enable the external interrupt to 1 to be triggered by the falling edge of the signal. It is not going for the leading edge, it is going for the falling edge. Set to 0 by the program to enable a low level signal on external interrupt 0 generate an interrupt. So these are the description of the each and every bit of the TCON register. Now this is one of the important register is the IE or interrupt enable register. Bit 7 is for the EA, bit 5 is for the ET2, bit 4 ES, bit 3 is ET1, bit 2 EX1, bit 1 ET0, bit 0 EX0. I'll explain one by one. EA, it disable all the interrupts. When EA is 0, no interrupt will be acknowledged and EA is 1, enable the interrupt individually. That means if it is 0, no other function is operating. E22 enable or disable timer to overflow interrupt. ES enable disable serial port interrupt. ET1 enable disable timer 1 overflow interrupt. EX1 enable disable external interrupt 1. ET0 enable disable timer 0 overflow interrupt. EX0 enable disable external interrupt. So this IE register basically used for the interrupt operation of the 8051 microcontroller. IP stands for the interrupt priority. The IP of interrupt priority register used to set the priority of the interrupt high to low. This bit is cleared, the corresponding interrupt is assigned the low priority, and if this bit is set, the interrupt is assigned the high priority. Bit 7, 6 is the reserve bit, 5 is all for the reserve, bit 4 is for the PS, serial interrupt priority bit 1, assign high priority to serial interrupt, 0, assign low priority to serial interrupt. Bit 3 PT1 timer 1 interrupt priority bit 1, assign the high priority timer 1 interrupt, 0, assign 0 priority timer 1 interrupt. Bit 2 is the PX1 external interrupt 1 priority bit 1 to assign the high priority external 1 interrupt, 0, assign low priority to external 1 interrupt. Bit 1 PT0 timer 0 interrupt priority bit 1 to assign the high priority to timer 0 interrupt, 0, assign the low priority to timer 0 interrupt. PX0 is for the external 0 interrupt priority bit, 1 to assign the high priority external 0 interrupt, 0 assign the low priority external 0 interrupt. These are the references. This is the end of today's lecture. This is my contact details. So this is the end of lecture 29. Meet you in lecture 30. Now if you like, please subscribe my YouTube channel. Thank you.